I'm working as a pen tester and I look for vulnerabilities in web applications all the time. But when you test a target, you usually don't know how much you missed. And that's why I like reading CTF and bug bounty write-ups, because they allow me to very quickly reflect on my own skill level. Could I have found these issues as well? And if not, why? Why would I have missed them? And that is a very, very important process for me, to be honest to myself, stay up to date and always push myself to improve. So in this video, I want to have a look at this year's top 6 bug reports in the Google Cloud Platform and see what I can learn from them. Every year, Google rewards the best vulnerabilities with the GCP Prize up to $137,337. So I want to go over the winners and share with you what I learned from them. And hopefully it is interesting and educational for you as well. So let's go. The first report is by Ademar Nowasky Jr., Command Injection in Google Cloud Shell. They also recorded a quick video how the attack would look like. So when you open this malicious link, it will ask you to clone the official Google Cloud GSUtil repository, confirm, then it takes a moment, sets up everything, clones the repository and opens the Cloud Shell editor, so an in-browser IDE with a shell. And then it tries to steal the victim's Google Cloud Access token. The core bug here is a command injection in the go-get parameter. You can see here the semicolon, and this is how the command looks like that is executed internally. So the injection here breaks out and you can execute whatever you want. As you can see, the report is very detailed and easy to understand, and I always love it when people explain the steps that led to the discovery, because on each step I can ask myself, would I have done the same? That really helps me, and I encourage you to do that as well. So Ademar describes that he researched the open-in Cloud Shell feature. As you saw, you can open a repository in this Cloud Shell. There's lots of documentation available, but what I found particularly interesting is that Ademar really dug into the JavaScript files that implements a lot of this. You know, sometimes I forget that on the modern internet, a lot of code is not executed on the server anymore, but more and more primary logic is implemented in client-side JavaScript. Usually, I don't like bug bounties because of the black box approach. I feel it's a waste of time just poking in the dark. But here I got reminded again, you might have access to all the code, and with your browser you can read it and even debug it. With these screenshots we are also getting a glimpse into how Ademar works. So the browser dev tools appear to be the primary tool used to investigate this. No burp seed or other web hacking tool required. Anyway, this bug was rewarded with 5K, and on top of that he got the 6th place in the GCP Prize and got an additional $1,000. Congratulations, Ademar. By the way, the issue is kind of similar to the vulnerability Wouter found in 2019, shown in my video Google paid me to talk about a security issue. But it's also interesting for me to see the differences, and you can tell that there were some significant changes, including these prompts asking and warning the users about certain actions. But let's move on. Remote code execution in Managed Anthos Service Mesh control plane by Anthony Weems. This issue is Kubernetes related, and my knowledge and experience with Kubernetes is so-so. I have made videos about how containers kind of work under the hood, but Kubernetes is a lot of stuff on top of that. It's a world of its own and extremely fast moving. So a write-up like this is actually kind of a Kubernetes tutorial for me. I'm learning about Kubernetes by trying to understand a vulnerability. Maybe that's weird, but that can be really useful. Anyway, this issue is specifically about Anthos Service Mesh, which is a Google product name. Under the hood, it is basically an istio deployment. I've never used istio before, so I don't really know much about it either, but reading this write-up I get a first idea of what it is about. However, the bug itself is more about a default misconfiguration allowing some lateral movement. So basically the attacker already has some access to Kubernetes, but is able to escalate it into the Managed Anthos Service Mesh. So Anthony figured out that he could deploy a malicious credential plugin. This is how it looks like, and it would execute this command when a secret is deployed. Please don't ask me what this is useful for. You can read the Kubernetes documentation about it yourself. As I said, I want to be honest with you and reflect if I could have found that. And to be honest, probably not. I don't know enough about Kubernetes and I've never read about credential plugins. But you know what? Now I know. Now I know this is a thing. So in the future, if I would ever face something similar, I can recall this memory. But anyway, that is just half of the bug. There is a second part, and that is that the command execution is not as simple as that. Turns out that the real container is stripped down and does not even have a shell or bash binary. There are only two programs available to execute: Pilot Discovery and OpenSSL. And this is where this whole thing turns into a CTF challenge. So here I really feel at home. Anthony figured out a way to only use OpenSSL to execute arbitrary code. He figured out that OpenSSL can load shared libraries, so basically loading and running a custom C program. That would be useful. Problem, of course, is how to get that .so binary file on the server. But look how he does it. First, he creates a certificate with a specific serial number. This serial number is huge because it's basically raw assembly bytes converted to a big integer. So this is how you can get an almost arbitrary file. There is some gibberish, but that is fine. The only real problem is, though, that this file does not start with the ELF magic header, which is required that this can be loaded as a shared library. But this is where AES decryption comes into play, a neat trick making the output a valid shared library. Very creative, and not sure if I would have been able to come up with that myself. From a technical skill perspective, nothing difficult for me. This AES trick explanation makes total sense for me from playing CTF. It's just the creativity that blows my mind. Coming up with that really inspires me. So congrats, Anthony. Wait a minute. I know this name. Anthony Weems. I collaborated with him on my Log4Shell fuzzing video. Yeah. So of course I used this opportunity to ask him some more questions, specifically what his motivation was to hunt for bugs in Google Cloud. My very first Google VRP submission was something I found on a client security assessment for work. After that process went so smoothly, every so often I would just do Google Cloud vuln research, mostly for fun. And he treated it like a CTF. That is his mindset for bug bounty hunting. I also asked him how he knew about the Kubernetes credential plugins. I vaguely knew they existed because I knew when I authenticated to Google Kubernetes Engine clusters, something had to update my auth token. So I just went looking in the docs and code for how that worked. And check this out. I interviewed at Google and I'm actually starting there next week on a team that does cloud vulnerability research. So for this bug, Anthony got a 5K reward plus a $1,000 bonus for the really cool exploit. By the way, a lot of Google security folks are from the CTF community, and I think it shows here. A CTF player would totally love this OpenSSL trick and give out that bonus reward. But on top of this regular reward, he also got top 5 best Google Cloud bug in 2021, so he got another $1,000 as a prize. And I guess a job at Google as well. Awesome. But we don't have much time. 4 more issues, so let's move on. The next write-up is from Imre Rad, the Speckle Umbrella story part 2. And this is a really long write-up because this article covers basically 6 different issues, but all around Cloud SQL. That is Google Cloud's product name for managed Postgres or MySQL databases. Unfortunately, there's just so much there that I cannot really dig into the details of this vulnerability. But there are a few things I wanted to highlight. Imre has done a lot of Google bug hunting before, and look at what he wrote here. After I proposed 2 additional attack vectors, the VRP team kindly assigned a research grant, so I had the chance to take a deeper look. The objective was to identify attack vectors enabled by a compromised Cloud SQL instance. A research grant basically means he gets paid to do bug bounty hunting. I find this interesting because a lot of people, including me, criticize bug bounties because people essentially work for free and only get paid if they find something. But a research grant changes that. You get paid a certain amount regardless of what you find. But if you find something, you get the bug reward for any of those bugs on top. And apparently Google has recognized that Imre really does valuable research into important areas, and they wanted to make sure he keeps looking by offering him a research grant. Anyway, the other interesting takeaway for me from this article is to see what it means to go deep into a particular area. For example, his issue number 5, Cloud SQL Auth Proxy leaking access tokens over network, man-in-the-middle attack. The Cloud SQL Auth Proxy is using SSL, but he noticed that the client certificate sent to the server contains the access token. And this certificate is sent before the encrypted tunnel is established. This already requires knowledge about SSL, but check out this quote about building a proof of concept attack. TLS implementations usually reject setting up a TLS listener without having the private key, so to demonstrate this, I built a tool on top of a patched version of Golang's TLS stack. The handshake is failing at the end, but at that point the client certificate has already been captured. Just taking an existing TLS implementation and modifying it to be able to show that the attack is possible. This is really showing me how much experience and skill Imre has in different areas of hacking. And overall, I really respect the persistence researching this area, the grind. You can really tell he tried to dig deep into Cloud SQL, and I probably would have given up much earlier. Anyway, Imre didn't disclose how much he got from the grant and from the different issues he reported, but you can imagine it all sums up. But on top of that, we know that he got 4th place and received an additional 31,337 GCP Prize. Congrats. Next one. Remote code execution in Google Cloud Dataflow by Mike Brancato. Dataflow is a Google Cloud product offering stream and batch data processing. So basically you have lots of data coming in and it can automatically spin up a worker and process that data. And look at the first paragraph what he writes. Earlier this year I was debugging an error in Dataflow, and as part of that process I dropped into the worker node via SSH and began to look around. Prior to that experience, I hadn't thought much about what was happening on the worker node, so I made a mental reminder to dig into Dataflow as a possible exploit vector into Google Cloud. Later that week, I spun up Dataflow in my personal Google Cloud account and started digging. Of course, I don't know for sure, but what I read here from between the lines is that he is working at a company that is using Dataflow, and he was investigating some errors, and it piqued his curiosity to look deeper into it as a possible exploit vector into Google Cloud. This is not uncommon. I really believe software engineers and programmers would be the best hackers because they are very close to the technology they are using. It just requires that special kind of hacker mindset to turn that programming knowledge into hacking knowledge. And one goal I have with my channel is to encourage more of that. I hope a lot of engineers in my audience develop this security mindset and they apply it at their workplace, uncovering new vulnerabilities, like Mike apparently did. Anyway, he investigated how Dataflow is implemented and noticed that a JMX port is open. JMX is the Java management extension, and it basically allows to remote control Java application, which is basically arbitrary code execution. And this port was exposed without authentication. However, it was firewalled and not reachable from the outside. So it was only reachable from your organization's internal network. But this again could allow an attacker to move laterally. So when an attacker compromised another internal service, they could spread to that Dataflow host. But as he writes, while exploitability from an internal system is a risk and interesting, it is unlikely to be valued or prioritized by Google. It's not publicly exposed. But Mike argued that customers might accidentally open up the firewall setting and allow a range of ports, and they probably don't know that they have this dangerous service now exposed. A passive scan also appears to show over 2,200 servers with this open port. And further, he argues that as a customer, the worker node should fall under at least the PaaS, Platform as a Service bucket of Google's shared responsibility model for cloud security. And this is what was most interesting to me here. Who is responsible for the security here? We all have somewhat an intuitive feeling about this, and in many cases it's kind of obvious. If I rent a server and I deploy and run a MySQL database, then I'm responsible to secure the port and create users with strong passwords. But if I use a managed solution like Google Cloud SQL, I expect Google to properly configure MySQL for me, but that's just an intuitive feeling, and that means others draw the lines differently. So it's very important that this is properly defined. And of course it is. Look at this responsibility chart. Mike argued that Dataflow is at least a platform offered as a service, PaaS, and in that case the network security and access and authentication falls under Google's responsibility. And that's probably why Google in the end agreed and rewarded him $3,133.7 bounty. Overall, this was a really straightforward report, and I really like the clear communication why he thinks this is a security issue Google should address. So this got third place for the best bug and write-up and got awarded an additional $73,331. Now I'm starting to feel like Mr. Beast again. It's not my money, I had no decision power who gets that money, but I don't know. I feel like I'm dropping cash here. Anyway, the second place report is from somebody we already know, Imre Rad, coming in with a double kill for his Google Compute Engine VM takeover via DHCP flood. I really like this one because DHCP hacks are kinda old school. In my 8 years of pen testing experience, not once have I done that. Not because I don't know about it, but because I never did a network pen test. But apparently I'm an idiot, because you could apply this to the cloud as well. Imre noticed that Google Cloud uses the ISC DHCP server. DHCP is a UDP protocol and Google Cloud uses it to get the IP address of the metadata.google.internal server. UDP is connectionless, so a VM will send out a DHCP request and waits for a response. But when they receive a UDP packet, how does it know that it's the response to the request? In the DHCP RFC, we can see that UDP packets contains a XID, which is used as a transaction ID, a random number chosen by the client and used by the client and server to associate messages and responses. So if a Google Cloud VM wants to contact the internal metadata server, it will have to discover the IP for this host. It will send out that DHCP request, and now if you as an attacker spoof the response packet, and you can guess the XID, then you can basically tell the VM, I'm the metadata server. This metadata server is used to load the SSH public keys onto the VM. So by doing that, you can basically deploy a malicious key on the VM and SSH into it. So Imre looked at the ISC source code to figure out how the random XID is generated, and he noticed that it was bad random seeding and it could be predicted, allowing an attacker to spoof the response packet. As you can see, clearly an issue for Google, but there is a very interesting discussion that you can read on the ISC bug tracker. Here's the public issue: improve pseudo-random number generator in the DH client, referencing the Google Cloud report. And here Tomek pointed out that according to the RFC, this random XID is not a security feature. A client may choose to reuse the same XID or select a new XID for each transmitted message. So making your security model dependent on an assumption that XID is hard to guess is not good practice. I agree, but then what is the correct way? Maybe the RFC has an answer for that? Let's see. Or they do have security considerations. Let's check that out. DHCP is built directly on UDP and IP, which are as yet inherently insecure. DHCP in its current form is quite insecure. Unauthorized DHCP servers may be easily set up. Such servers can then send false and potentially disruptive information to clients, such as incorrect IP addresses. Clearly, once the seed information is in place, an attacker can further compromise affected systems. Oh my god, I mean, at least it's honest. But this is what makes this discussion so interesting, right? This is just how DHCP works, and they knew that since 1997. Which means, is it really something ISC should fix? Or is Google at fault here because DHCP is just the wrong solution? Imre argued, while a pseudo-random number generator with more entropy sources could have prevented this flaw being exploitable in GCP, I still think this is not a vulnerability of their implementation. And maybe Google should just not use DHCP or set up firewalls blocking UDP port 68. Which sounds fine, but then Eduardo from Google pointed out on the ISC issue tracker that an unprivileged local attacker can still reach that port and basically man in the middle any other user on the system. making it somewhat a privileged escalation exploit, and proposed that the DH client should at least check the source port. Very fascinating discussion and provides a lot of food for thought. Let me know in the comments how you think about it. Unfortunately, we don't know what Imre got for this bug report either, but we do know that it got him second place with an additional $73,331 reward. And now we come to the winner of the Google Cloud Platform Prize of 2021, the best bug report, Bypassing Identity-Aware Proxy by Sebastian Lutz. This is again a bit more of a traditional web security bug, no Kubernetes, networking, TLS, whatever, plain web security. Basically an OAuth vulnerability. Identity-aware proxy is pretty cool. It's exactly what the name says. It's a web proxy, so when you use it, all requests to your website go through that proxy, but the proxy is identity-aware, so basically you have to authenticate yourself, log in with your Google account, and only then you can actually access the site. And IAP enforces an OAuth authentication flow before access to the actual application is granted. Sebastian explains how exactly the whole authentication flow works and tells us how he figured out the bug. And as you know, I want to figure out if I could have found this vulnerability as well. So the most interesting line for me in this write-up is here. He explains that he stumbled over a specific feature of the identity-aware proxy, that is that the configured OAuth client can be shared for convenience with other services across the same organization. But for me, this caused a sudden shift in perspective and led to a breakthrough for bypassing IAP. What would happen if I tried to create an IAP secured application as the attacker, but specified the target OAuth client using sharing OAuth clients feature? This research question, this is gold for me. You know, when you look for vulnerabilities and when you do security research, sure, you need experience and lots of technical knowledge, but once you have a good foundation, then creativity and having new and weird ideas, that's what becomes most important. So being able to formulate research questions like this is just perfect. And it's hard for me to say if I would have come up with this as well. Maybe, maybe not. From a technical perspective, sure, I know web stuff, I understand the vulnerability, but the creativity to test for this, that is the key to everything. So yeah, it's a really cool write-up. Thanks for sharing your thoughts. And so the original bug was rewarded with $5,000. But as you know, this is also the winner. So congratulations for winning the Google Cloud Platform Prize 2021, earning an additional $137,337. Crazy. Oof, as you can tell, the video is getting quite long. Thanks for sticking with me all this time, but I have a few more thoughts I wanted to share. What differentiates the winner from the other issues here? Well, it's kind of the only attack from outside. This is something a malicious outside attacker could do. Well, okay, Play 6 was also doable for an outside attacker, but there were at least 2 prompts a user had to click. But here, it's not the case. And all other issues are more about lateral movement within the network. Google Cloud has network separation between organizations, so between different customers. So these networking issues, I think, only apply within an organization. So an attacker has to compromise another server before they could exploit any of the other issues. Also, I think what is noticeable is how detailed all these write-ups are. Some are more complex than others, but generally I was able to understand and follow all of them. And I think that's also a big reason for why these are the winners. Of course, it's important to find a cool vulnerability, but the prize is not just about that. These write-ups specifically are the winners. So the quality of the write-up and the clear communication is extremely important as well. Thanks again, Google, for sponsoring this video. It still baffles me all the time that a company pays money to share security vulnerabilities with a big audience. I mean, most companies try to sue and prevent people from talking about stuff like that. So to me, this is still mind-blowing. Anyway, I hope these write-ups inspired you to maybe consider bug hunting on the Google Cloud platform as well. And of course, if you find a cool bug and you write a good report, then you also have a chance to win the next GCP Prize. So good luck to you all. You have about 6 more months. I hope I can read about your bug next year.